We've now made it to lesson 25, and this is about triangles and quadrilaterals. This video is going to cover triangles, lesson 25A. And there's links in the video to help you if you need it, okay? Every triangle has 3 sides and 3 angles. And they're named and labeled with capital letters at their vertices. So see the vertex of here, A, and the vertex B and the vertex C? And we can use this little triangle symbol, an ABC, as notation for triangle ABC. And it doesn't matter the order of the letters. We can call it BCA. We can call it CAB. Any one of these would identify that triangle. The order doesn't matter, but remember the center letter tells us the vertex of an angle. So if we just have an angle, see, it's not a triangle, there's no line here. We just have angle ABC. The B is the vertex, so that's in the center, see? So keep that in mind, all right? And there's little tick marks that show congruent sides or angles. We have this angle is congruent to this angle, so they're the same measure, and that little 1 tick mark matches the other little 1 tick mark in the angle, see? This side has 2 tick marks, and so does this one. That means they're the same length. The 2 tick marks match the 2 tick marks. And if we had a bigger polygon, it might have 3 tick marks on a side that match 3 tick marks on another side, okay? Or 4 matches 4, and so on. Depends on how big the polygon is. This is just an isosceles triangle, so these 2 sides are congruent, and these 2 angles are congruent, all right? We've got this right triangle, and I color-coded it to make it easy. And we use the 2 letters at the vertices from each angle to identify that side. So here we have the vertex A and the vertex B, and to identify this blue line, it's line AB. We use the labels from the vertexes, see? From the vertices. And here's line AC and line BC. And the entire triangle is named for the length of its size, such as equilateral triangles have 3 equal sides. This side and this side and this side are all the same length. They're all equal. So it's equilateral. Isn't that easy to remember? And it has 3 equal angles. See? That angle and that angle and that angle all have a little tick mark on them. That means they're all the same measure. And they all equal 60. An isosceles triangle has 2 equal sides, but it has also 2 equal angles. And a scalene triangle, that's how it's pronounced, scalene, has no equal sides, no equal angles. This one's really long, that one's medium, that one's short for the sides, and then the angles are all different measures, okay? Or they could be named for the measures of their angles, such as a right triangle. It has 1 angle that's 90 degrees. And you usually are going to see a little box there, but you may not, and I'll show you as we continue in the video. Now, it's got this little box for this right triangle. We know it's got 1 90-degree angle. It can only have 1. If it had 2 right angles, it wouldn't be a triangle. It would be square-shaped, wouldn't it? See that? 2 right angles, it wouldn't be able to close, so it wouldn't be a triangle. Acute triangles have 3 angles that are less than 90 degrees. So remember, acute angles are less than 90 degrees. They're cute and little. So all 3 of these are less than 90 degrees. An obtuse triangle has 1 angle that is obtuse, that's greater than 90 degrees. Just 1, see? If it had 2 obtuse angles, it wouldn't be able to close, and it wouldn't be a triangle, okay? It's got to have 1 obtuse one and then 2 acute ones, okay, in order to be an obtuse triangle. For all triangles, the sum of their interior angle measures is 180 degrees. We can use this fact to find missing angle measures inside triangles. So here's a right triangle. We can see that because of the box here, and it's telling us that this angle, B, is 50 degrees. So what's the measure of angle C? Well, it's got to equal 180. We take the measure of angle A and B and C to equal 180. So we know that measure of angle A is 90 and B is 50. 90 and 50 makes 140. Now we add a negative 140 to each side of the equation, and we see that the measure of angle C must equal 40 degrees. We also could just say, well, we know it's 180, and 90 and 50 is 140, so 180 minus 140 is 40, and you can do it quickly like that. But I want you to be able to recognize the equation, because that might be on the test. It might say which equation will solve this. Okay, so you want to be able to see this. Now take a look at this one. This is a scalene triangle, isn't it? It's got all different measures for the sides, all different lengths, and all the angles have different measures. This one's 105, that one's 25 degrees. So it says, what is the measure of angle QPR? So it wants to know this angle measure. So if we add all the three angles up, it should total 180. We know that one's 105 and that one's 25. If we add these together, we get 130. That's combining like pairs, like terms, isn't it? So now we have 130. So we know that this angle plus 130 will equal 180. We add a negative 130 to each side of the equation, and we isolate the P, the angle P. This creates a zero pair. We get 50 degrees. So we know that one's 50 degrees. Okay? So it really helps knowing that there's 180 inside. And take a look at this drawing. We've got a triangle with lots of triangles on the inside. And it's asking us, what is the measure of angle SUW? SUW. So we're ignoring T. Pretend like that line isn't there. It wants to know the measure of angle SUW. So it wants to know this angle right here. So we've got our work cut out for us. It says this is 42 degrees. We know that this is a right angle right here, but you know what? If that's a right angle, then this has to be a right angle. See that? So we know we've got 42 and 90, because we're ignoring T, and that should equal 180 with the U, shouldn't it? So we do 42 plus 90 and get 132, and if we take that away from the 180, we get 48 degrees. We know that that is 48 degrees right there. Okay, so we've solved that one. All right. It says, what is the measure of angle SUV? SUV. Oh, now it wants this whole thing. How can we find that? Well, you know what? All we have to do is find this little side here and then add these two together, don't we? We know that's 60 and that's 90. So that would be 150, and in order for this to total 180 with this measure and that measure, that would have to be 30, wouldn't it? So we can use this triangle to help us solve for that whole angle. See that? So we know when we add these together, it's 78 degrees. So this angle here is 78 degrees. It's these two combined, see? What is the measure of angle WUV? WUV. 30 degrees. We just figured that out, didn't we? It's 30 degrees. What is the measure of angle SWT? SWT. So it's this one right here. We know that these two together are 90 degrees. It wants this one. Well, we know that that's a right angle, that's 90 degrees, and we know that's 42. We can add those together and figure out that it's 48 degrees. So we know this one is 48 degrees. See? What is the measure of angle UTW? UTW. So it wants to know the measure of this one right here. Well, you know what? If that's a 90-degree angle and that's a straight line, then that's a 90-degree angle. It has to be. See? Now it's asking how many right triangles are in the diagram. Well, there's actually 4, because we've got this one here, right? That's a right triangle. We've got this one here. That's a right triangle. We've got this one here. That's got a right angle in it. And if you ignore this line T, we've got this big one that is a right triangle. See? So there's 4 of them. And when it first showed us the diagram, this wasn't here, and this wasn't here. So we just had to know that if that was 90 degrees, that side was 90 degrees if you ignore this line T. See, that's a 90-degree angle right here. And if that's 90 degrees, that's 90 degrees, because the supplementary, they'd have to be 180, wouldn't they? All right? Okay, it says in a right triangle, the measure of one acute angle is 8 times the measure of the other acute angle. What is the measure of the larger angle? So it can sound confusing, but we know that we can break this into little baby parts and it makes it easier. It says it's a right triangle. Ah, that means one of the angles is 90 degrees, doesn't it? So we've already got one measure. It says the measure of one acute angle is 8 times the measure of the other acute angle. So they're acute, so they're less than 90 degrees. So you have a 90-degree one and then 2 smaller ones. So we're going to let X represent the other acute angle. That's this one right here. Okay? That's going to be X. Then we've got an acute angle that's 8 times this one. So it's 8 times X. It's 8X. Then we have that 90-degree one because we know it's a right triangle. Now we have our equation. We have X plus 8X plus 90. We can combine the like terms here and get 9X. We have 9X plus 90 equals 180 degrees. We can create a zero pair here by adding a negative 90 to both sides of the equation. And then we get 9X equals 90. When we divide both sides by this 9 coefficient to isolate the X, we get 1X equals 10 degrees. So we know that this one is 10 degrees. So if this one is 8 times 10 degrees, it's got to be 80. So that larger acute angle must be 80 degrees. All right? So the hardest part here was breaking it into little parts and assigning the variables. So you want to just find the one that can be the X and then see that this one is 8 times it, so that's 8X, okay? And then pay attention to the clues, like right triangle means there's going to be a 90-degree angle, all right? Let's try that again, because these can be confusing, and I know there might be on the test, all right? So in a triangle, the measure of one angle is 22 degrees more than the measure of the smallest angle. And the third angle is twice the measure of the smallest angle. What are the 3 angle measures? Holy cow. All right, we need to break this into little parts. So it doesn't tell us what type of triangle, so we're on our own, aren't we? There's no right triangle here with 90 degrees. But it does tell us the measure of one of the angles is 22 degrees more than the smallest one. And it does tell us that the third one is twice the measure of the smallest one. So look what they're doing. Everything's being compared to the smallest one. So the smallest one is going to be our clue. We're going to let S equal smallest. When I do algebra, I like to use variables that remind me of what I'm doing so I don't get lost and confused. So if I'm looking for that smallest angle, I'm going to use an S for smallest. Then we know that this one is 22 degrees more than the smallest, so that's going to be smallest plus 22. It's 22 more than it. The third angle is twice the smallest, so it's going to be 2 times the smallest, 2S. We know that they all equal 180 because it's a triangle. We have our equation. We have S plus 22 plus 2S equals 180. We combine the like terms. The S and the 2S, that's 1, 2, 3, 4 S's. So we have 4S plus the 22 equals 180. Now we can get rid of this 22 by adding a negative 22 to both sides of the equation, create a zero pair here. We get 4S equals 158. Now all we have to do is divide both sides of the equation by that 4 coefficient, don't we? That makes a giant 1. Same numerator and denominator makes a 1S. 158 divided by 4 gives us 39.5. 39.5. So we know that S equals 39.5. Now, if that other one was the smallest one plus 22, then we do 39.5 plus 22. We know the next angle is 61.5. And the third angle was 2 times S, so it's 2 times 39.5. That's got to be 79 degrees. We add the 39.5, the 61.5, and the 79, and when we add them all up, make sure your decimals are straight, we see that they total 180 degrees, so that means we made a triangle. It's 180. We did it right. Okay? So, because it was comparing everything to that smallest one, I knew that was going to be our X, or in this case, our S. And then we did a plus 22 or a 2s to represent the other ones, okay? So that's going to be the toughest part, is putting it into an equation. But if you look at it and break it into little baby parts, that's what will help you, okay? Let's take a look at this one. We've got another triangle with a lot of triangles inside, and we can see vertex A, B, C, D, and we can see we have a right angle here, we have a right angle here, but that kind of tells us there's going to be a right angle here too, isn't it? Right? Because they both have to equal 180 to be supplementary. All right, and this is 55 degrees. So true or false, is the measure of angle BAC 35 degrees? BAC, is this measure right here 35 degrees? Well, how can we find out? Well, if that's 90 degrees, that's 90 degrees. Because it has to be, right? To be 180, to be supplementary, going like this, which means we know that's 90 and that's 55. If we add the 55 and the 90, we get 145. So the only thing left for this triangle to be 180 would be 35. So yeah, that's true. So we had to do a little detective work, but we figured it out. Okay. Is the measure of angle CED 70 degrees? CED. It wants to know if this one is 70 degrees. Well, you know what? The definition of a supplementary angle says that this has to be 180. And if that's 110, then yeah, that would be 70. That would make 180, wouldn't it? And it would be a supplementary angle with that one. So that is true. How about triangle AED is an equilateral triangle? Let's find triangle AED. AED. Okay, so it's talking about this bottom one here. Is that equilateral? Are all the sides and angles equal? No, this side's way longer than that one. So that one's false. That's not an equilateral triangle there at the bottom. It says the measure of ADE is 25 degrees. ADE. Is this one 25 degrees right here? It's talking about that angle right there. Is that 25 degrees? How can we find out? We know that's 110, and the BAC we found was 35 degrees, didn't we? So we found that was 35 degrees. We already did that work. Well, that's a right angle, isn't it? So what would this need to make this 90 degrees and be complementary? Wouldn't that have to be 55 on this side? So now we have 110 degrees and 55 degrees. What could that one be? So we have 55 degrees and 110 degrees. That makes 165. When we do 180 degrees for a triangle minus the 165, we only get 15 degrees. So is the measure of angle ADE 25 degrees? No, that's false. And here it says there are two right triangles. Do you see two right triangles? Well, I see the big one, the big huge one, the outer one, that's one. Then I see this one here, that's another right triangle. And then I see this little one here, there's three. So there's three right triangles. So are there two right triangles? No, there's three, so that's false. Okay? So remember, complementary angles total 90 degrees, supplementary angles total 180 degrees, and that all interior angles of a triangle total 180 degrees. If you can remember this, that's going to really help you, because you'll be able to just breeze right through here using those rules to help you find the answers, okay? I have one last one for you. We've got this shape. We can see there's a 90-degree angle here and a 90-degree angle here. This is 124. That's 62. And our vertices are labeled. It says, which of the statements about this figure must be true? So not we think it's true, that must be true, that we can actually prove. It says the measure of angle AED is 62 degrees. AED. Is this measure right here 62 degrees? Well, in order for this to be a supplementary angle, we'd have to add it with the 124 to be 180, wouldn't we? Is 124 plus 62 180? No, it's 186. So that one's not true. We know it's not number one. How about Angle BEC and CED are vertical angles. Angle BEC, so that's this angle right here. Let me get rid of that. So it's this angle right here, and CED, this angle. So are that angle and that angle vertical angles? No. Vertical angles go across from each other. They're opposites, right? So those would be vertical, but these two are supplementary. So that's not right either. It's not number 2. How about that triangle ABE is an equilateral triangle? ABE. Is this triangle here equilateral? Are all the sides and angle measures the same? No, look at how long that side is, and that one's real short. So it's not 3 either. How about the measure of angle ABD is 28 degrees? ABD. So it's asking us if this angle measure right here is 28 degrees. Well, it might be. It could be. Let's look at number 5 and see what's going on. CBE, so it's saying this one right here, and ABE, so this one and this one, these two angles are supplementary. Well, that's a 90-degree angle. That's not supplementary, that's complementary. So that can't be true. So it's not that one. So guess what our answer is? It's got to be number 4. Now, you could go on to the next problem, mark number 4 as the correct answer, and trust that if it can't be these, it's got to be that one. Or you could continue and try to solve it. So what we do is, we know that ABD, this angle right here that we're looking for, it's supposed to be 28 degrees, that if we add it together with ADB, this one, which is 62 degrees, and if we add it with this one, which is 90, then it should total 180. So, to find this one, we add the 62 and the 90 degrees here. We ignore this line because we're just looking at this whole big triangle here, okay? So we're going to add the 62 and the 90. We get 152, so we add a negative 152 to each side of the equation, create a 0 pair here, and we get that the measure of angle ABD must be 28. So yeah, it was 28. And like I said, you really probably didn't have to do that. If you absolutely are sure, without a doubt, that these are not it, it's got to be that one, process of elimination, right? Okay, so you should now be ready to do the skill focus on page 299 and try to do what it says. If it says to use the calculator, go ahead. If it says not to, then don't. And try to memorize the types of triangles. You can either make 6 little flashcards and quiz yourself, or if you're really into art, you could try drawing something with these 6 triangles to figure out a way to help you remember their names and their rules, okay? Because that's going to help you. If it tells you that there's a scalene triangle, then you say, oh, okay, I know right away the sides are all different. Or if it says in a word problem, an isosceles triangle, has a side of 2 inches and another side of 4 inches, could the third side be 8 inches? Say, well, no, it's got to either be 2 or 4 because they've got 2 equal sides. 2 of the measures have to be the same. So make sure you know what these mean, okay? That's going to be really, really helpful to you. Our next video is going to be quadrilaterals, 25B. We're going to talk about squares. We're going to talk about rhombuses and trapezoids, and we're going to do rectangles and parallelograms. And if you need help with any of this triangle stuff, these middle school videos can help you. And then I've still got links to the previous lesson 24 for the lines and angles to help you out. All right? So I know this video was long, but we're packing so much information in because I'm trying to teach you all of high school geometry in 5 lessons. That's a lot, okay? That means the videos have to be longer. So I'll see you next time. Keep your chin up. Keep trying. I'm proud of you. Bye.